All right, the first lesson of our statistics unit is going to be on scatter plots and lines of best fit. Now, please make sure that you are paying close attention to this because this is the hardest lesson of the unit. Once you're okay with this lesson, the rest you'll be fine with. All right, so first of all, we need to define several different words. These 4 words are going to be really important for the foundation of this unit. So the first the first phrase that we need to define is qualitative or categorical data. You can use either word, qualitative or categorical. They are interchangeable, but it's just data that is represented as a description. So an example of something that would be qualitative would be someone's hair color, for example, or someone's hobby. Okay, those are examples of qualitative data. Now, quantitative data is data that is represented with numbers. So something that when you ask somebody a question, they're going to give you a number as an answer. So an example would be like your age or your height. Okay? And when we talk about quantitative data, we will be using scatter plots, just so that you know. If it is bivariate. Bivariate data means that there's 2 variables of data that are compared with each other. By the way, if you need to, make sure you press pause so you can get all of this information down. An example of 2 variables that you would have that you could compare with each other is somebody's height versus their weight. Okay? So you have an x variable and you have a y variable, an independent variable and a dependent variable. Now the last vocabulary word is an outlier, and that's a value that lies outside of the data, and we'll talk about that in a little bit. Okay? All right, now if you look right here, these examples of these graphs right here are all scatter plots. And the reason why they're called scatter plots is because they're plots with scattered dots on them. So describe the association between the bivariate data. It's bivariate because you have an x variable and you have a y variable. An association can be strong or weak, positive or negative, and linear or nonlinear. So this one right here, I would say that this association right here is moderate. It's not strong and it's not weak. It's not in a perfectly straight line, but it's not totally scattered. So we would say that this is moderate association. And we look at the direction that the graph is going. This is going down, so we would say that it is negative. And lastly, it looks like it is in the general pattern of a line, so we will say that it is linear. Okay? Now in graph B, if you look at it, there really is no connection between your x and your y variables because the graph is completely scattered. So it has a weak association. And because of that, it's really hard to tell if it's positive or negative or if it's linear or nonlinear because it's totally scattered. So go ahead and try graph C and graph D, see what you get. Okay, so for graph C, I would also say that it has a weak correlation or a weak association. And then for D, I would say that it is pretty strong actually. And it's increasing, which means it's going up. And if you look at it, the general pattern of the graph looks like it is going in a curved line, which means that, in a curved pattern, which means that it is nonlinear. Okay? All right, the table below shows the results of 10 students throwing a ball. Construct a scatter plot for this data. Use 1 centimeter on the horizontal axis to represent 2 centimeters in height and 1 centimeter on the vertical axis to represent 5 meters. First of all, we need to label our different axes. So this axis right here, we're going to say is height because it tells us that the height is x in the problem right here, and height is measured in centimeters. And then on the side, we're going to say that this is distance thrown. Okay. And we're going to say that this is measured in meters. And again, we know this is distance thrown because it says that the distance is the y. So it says use 1 centimeter on the horizontal axis to represent 2 centimeters in height. But this right here is always going to be 0. So I have to put a break in my graph. Now I'm going to start at about 154 right here, only because it appears to me that the smallest value that we have is 154. There are no values that go below that. And it says to use 1 centimeter to represent 2 centimeters in height, which means that every block will be up 2. So this is 156, 158, 160, so on and so forth. Okay, this is 162, 164. I'm sorry, it's not very clear, the writing right here. Okay, this right here would be 166. This right here would be 168. And then this right here would be 170. And I think that's a good place for us to end for this one. All right, and then it says to use 1 centimeter on the vertical axis to represent 5 meters. And it looks like our lowest value is about 45. So I will put a break in my graph again right here. And then I'm going to change, or I'm going to start right here at I'm going to start right here at 40. So this will be 40, this will be 45, so on and so forth, 50, okay. Hopefully yours will be a little bit neater since you're doing it with a pencil and paper and I'm doing this on the computer. This will be 60, 65, 70, and 75. Now to construct a scatter plot, all you have to do is put dots where the points are. So, and you're not going to connect any dots. So for example, the first dot that I'm going to place is 158 or 154, 48. So I'm going to go to 154 for the height in centimeters here, and then 48 right here. So this right here is going to be my first dot. My second one will be at 160 with 50. Go ahead and construct the rest of your dots and see how you do. Compare your dots with mine. So 161. 161 will be halfway in between. So go to 161 and 60. Go ahead and press pause. And then when you're done, come back to this graph right here and see if yours looks like mine. A scatter plot that looks like this, if you see all of the green dots, this represents all the students' data that we had. Now, not every student is going to have the same exact information, and that's what this data tells us right here. So we can use this data to help us predict information in the future. We'll talk about that in a little bit. But if you notice right here, there seems to be a pretty strong correlation between how high you throw a ball and the distance that it is thrown. So we're going to say that there is a strong correlation, and that the correlation or the association is positive because it's increasing. So the higher you are, the larger the distance thrown is going to be. That's what the general pattern seems to be saying based on the scatter plot. All right, now the whole point of a scatter plot is to have a line that best describes the data so that we can use it to help us predict what a certain outcome would be based on the data that we have here. So in this example, we have yield of a chemical reaction. So it's obvious that as the temperature is increasing, the yield in grams is going to decrease. So as the independent variable increases, the dependent variable decreases. So generally you would draw in your line of best fit approximately where you think it would be. But this is drawn in for us, and if you notice, it's drawn in such a way so that the line goes through the data and it's a good description of the data. That's why it's called a line of best fit. It best fits the data. So how do I find the equation for a line of best fit? All I have to do is pick 2 points on my graph and find the equation of those 2 points. Just like we learned when we learned how to find equations of lines. So I'm going to choose 2 points on my graph. The first point I'm going to choose is this point right here. It's clear that the point is at 55 degrees Celsius and 22 grams. So this coordinate right here would be 55, 22. And then I would do the same thing for my other coordinate right here, and this coordinate appears to be 65, 20. So I'm going to plug it into my slope formula. So I'm going to do y2 minus y1. So I'm going to say 20 minus 22 over x2 minus x1, 65 minus 55. I end up getting negative 2 over 10, which is negative 1/5, which makes sense. As the temperature increases by 1 degree, the yield will decrease by 5 grams. Okay, so that's the m. Then I would just use y equals mx plus b to find the starting amount. So y equals mx plus b. And I know that the m is negative 1/5, so I'll use negative 1/5 right here. And then I'm going to take any coordinate I want, plug it in. I will choose 55, 22, so I will plug in 22 for y. And then I will say equals negative 1/5 multiplied by 55 plus b. And here, to figure this out, I'm just taking 55 and dividing it by 5, so I would get 11, but it's a negative 1/5, so I would get a negative 11. So I end up getting 22 equals negative 11 plus b. Okay, then I would add 11 to both sides, and I would end up getting 33 equals b. All right, so that means that my equation for my line of best fit would be equal to y equals negative 1/5 x plus 33. Okay. Next time I see you in class, we will talk a little bit more in depth about this equation because there's something that you should notice that is a little bit strange, and we'll talk about why it's strange. And we will also answer questions 2 and 3 tomorrow in class. Okay?